This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Hello and welcome to this special episode of the ESOcast. Leading up to ESO's 50th anniversary in October 2012, we will showcase 8 special features portraying ESO's first 50 years of exploring the southern sky. Bigger is better, at least when it comes to telescope mirrors. But larger mirrors have to be thick so that they don't deform under their own weight. And really large mirrors deform anyway, no matter how thick and heavy they are. The solution? Thin, lightweight mirrors and a magic trick called active optics. ESO pioneered this technology in the late 1980s with the New Technology Telescope. And this is the state of the art. The mirrors of the Very Large Telescope, the VLT, are 8.2 meters across, but only 20 centimeters thick. And here's the magic. A computer-controlled support system ensures that the mirror keeps its desired shape at all times, to nanometer precision.
The VLT is ESO's flagship facility. 4 identical telescopes joining forces on top of Cerro Paranal in the north of Chile. Built in the late 1990s, they provided astronomers with the best available technologies. In the middle of the Atacama Desert, ESO created an astronomer's paradise. Scientists stay in La Residencia, a guest house partly buried under the dirt and rubble of one of the driest places on the planet. But inside are lush palm trees, a swimming pool, and delicious Chilean sweets. Of course, the unique selling point of the Very Large Telescope is not its swimming pool, but its unequalled view of the universe.
Without thin mirrors and active optics, the VLT wouldn't be possible. But there's more. Stars appear blurry, even when observed with the best and largest telescopes. The reason? The Earth's atmosphere distorts the images.
Enter the second magic trick, adaptive optics. On Paranal, laser beams shoot out into the night sky to create artificial stars. Sensors use these stars to measure the atmospheric distortions, and hundreds of times per second, the image is corrected by computer-controlled deformable mirrors.
And the end effect? As if the turbulent atmosphere were completely removed. Just look at the difference.
The Milky Way is a giant spiral galaxy, and at its core, 27,000 light-years away, lies a mystery that ESO's Very Large Telescope helped to unravel. Massive dust clouds block our view of the Milky Way's core, but sensitive infrared cameras can peer through the dust and uncover what lies behind. Assisted by adaptive optics, they reveal dozens of red giant stars. And over the years, these stars are seen to move. They orbit an invisible object at the very center of the Milky Way. Judging from the stellar motions, the invisible object must be extremely massive. a monstrous black hole weighing in at 4.3 million times the mass of our Sun. Astronomers have even observed energetic flares from gas clouds falling into the black hole, all exposed by the sheer power of adaptive optics.
So thin mirrors and active optics make it possible to build giant telescopes. And the adaptive optics take care of the atmospheric turbulence, providing us with extremely sharp images. But we're not done yet with our magic tricks. There's a third one, and it's called interferometry.
The VLT consists of 4 telescopes. Together, they can act as a virtual telescope measuring 130 meters across. Light collected by the individual telescopes is channeled through evacuated tunnels and brought together in an underground laboratory. Here, the light waves are combined using laser metrology and intricate delay lines. The net result is the light-gathering power of 4 8.2-meter mirrors and the eagle-eyed vision of an imaginary telescope as large as 50 tennis courts. 4 auxiliary telescopes give the network more flexibility. They may appear tiny next to the 4 giants, yet they sport mirrors 1.8 meters across. That's bigger than the largest telescope in the world just 100 years ago.
Optical interferometry is something of a miracle. Starlight magic wielded in the desert. And the results are impressive.
The Very Large Telescope Interferometer reveals 50 times more detail than the Hubble telescope. For instance, it gave us a close-up of a vampire double star. One star is stealing material from its companion. Irregular puffs of stardust have been detected around Betelgeuse, a stellar giant about to go supernova. And in dusty disks surrounding newborn stars, astronomers have found the raw material of future Earth-like worlds. The Very Large Telescope is mankind's sharpest eye on the sky. But astronomers have other means to expand their horizons and broaden their views. At the European Southern Observatory, they have learned to see the universe in a completely different kind of light.
This is Dr. J, signing off from this special episode of the ESOcast. Join me again next time for another cosmic adventure.